All right, so maybe we can start off. Hello, everyone. Good evening. Hope you all are doing well. Hope you're having a good week and a weekend. I know it's a weekend, it's a Saturday, but we have a very interesting workshop today. So far we have had 4 workshops where we have focused on the technical parts of water management and water governance. So in the last workshop, we touched upon groundwater and the different aspects to it, what can be done, the impacts of groundwater contamination. So today is a slightly different workshop. Today's workshop is a skill-based workshop, which will help you as a young water champion. So as part of our program, we're focusing on both the technical knowledge and the other part is the skills that are needed for you to advance the work in water management that you want to do. So throughout this process of it's been almost like more than I guess 2 months now that we have been associated. We have also asked you to identify a problem, a local problem, the solution to it, and what you as a young water champion would be doing to drive that solution. I hope you are thinking about this seriously, because we would love to see that happen. What kind of support you need, that's also something we are ready to offer. We just want to know your solutions, what kind of actions you will take up. So a couple of things to share with you all before we begin with today's interesting session. First of all, please use the chat box to share what are your expectations from today's session. So today's session is about the fundamentals of GIS mapping. GIS mapping, as you know, is so important, not just in terms of identifying, it's not just a visually appealing sort of a thing that you see, but it also helps in decision making, in planning. So I don't know how many of you have heard of GIS mapping before, but since you have joined this workshop today, what are your expectations? What do you hope to learn? Please share in your chat box. I'm sure our speakers today will be able to address those as well. So it's going to be a very fun session. Secondly, we plan to share all the recordings of the workshops with you. We will also share it in the WhatsApp group. So please do utilize those recordings if you have missed any particular workshop, to know about what happened during the workshop. There is so many discussions both on your personal communication skills, both on your technical knowledge. So I hope you would not want to miss that. The third thing, a very important thing, is we want you to fill up a form. Now that we have carried forward this journey for over 2 months, so much has been learned. Now it's time to act. Okay, so we'll share a Google form with you. So you need to fill it up. Basically, you need to describe the problem statement that you have identified. What are the solutions and what kind of actions you will take to reach those solutions? And then what kind of support do you want to make that happen? And let's be realistic when we are kind of thinking around this. We had some sessions where we also talked about how youths can act around different aspects of water management, right? So go to the recordings if need be, get in touch with us if you want to understand more, but do fill this up. This form is really important. And another part of this particular form would be, what are your key learnings from this particular program, from the workshop series? Now, why are these things important? Because we would want to support you in the action you take. That is a key part of it. And we want you to, as a young water champion, we would want you to step up and actually act. The third thing is, we are preparing this report on youth and water. And this report, we intend to submit it to the government of Assam. So all the insights that you will be sharing with us will actually go into the report with your name, of course, as a young water champion. So pull up your socks. Please do share your insights into that report. You need any help, I'm sure you must be having my contact number, Pranab's contact number, Jatin's contact number, Himadri's contact number. So we all are there to help you. Do reach out to us. We would be more than happy. And the fourth thing that I wanted to share is, if you guys want to meet up in Guwahati, we would love to host you. So let us know. We can all meet up also to have some discussions now that we have completed so many workshops. We would be excited to do that. So maybe to begin with, please use your chat box to share what do you expect from today's training? Maybe one word around it if you want to share. What do you want to learn from today's training? So if all of you can type in your chat box, and then we can sort of proceed. I would also love to welcome our two speakers today, Shaurya Bajaj, who is one of our team members from Global Shapers Community, Guwahati Hub, and Mr. Arup Das, who is also part of Aaranyak. These two are the people, the GIS people that we call, who will be taking this fabulous workshop today. Okay, Jatin shares he wants to become a master of GIS mapping. Yes, even I want to I want to know GIS mapping for that. But maybe if anyone wants to share actually, right, not just type, like Bornav, do you want to share what are your expectations from today's training? Are you there, Bornav? Okay, Pranjal has shared utilization of GIS in low-tech. Pranjal, can you share what low-tech is? Maybe you can unmute yourself, Pranjal. We have a very interactive session, so you can unmute and also share. Not a problem. This is an interesting term.
Yeah, so low-tech basically means the flowing water systems, which flows like rivers.
Right, interesting. Nice. Basic introduction to GIS mapping. Fantastic. Great. Mayurakshi, what are your expectations?
Yeah, so I have heard about GIS mapping, and I look to this opportunity as a starting ground for understanding of that. So yeah, let's see.
Sure. Thank you so much. So you guys can actually share your expectations. Please use the chat box to also post your questions. Please note today's session is going to be very basic. It will give you an introduction to GIS mapping, but GIS mapping in itself is a very complex course or a study or a domain in itself. So we hope that after today's session, you are interested, you enroll yourself for a session on GIS mapping in any of the online courses, etc. So we may not have all the answers, but what our speakers will do today is take you through what this is about. Where can you get the data? What do you need to become the master of GIS mapping? So welcome everyone. Welcome to our speakers. Welcome to our young water champions who have been part of our program for so long. Welcome to new people who have joined us today for this particular workshop. So let me begin by introducing our speakers today. So we have with us Shaurya. So Shaurya is a member of Global Shapers Guwahati Hub. I'll give that first introduction because he is our team member. Fantastic guy. He knows like GIS is his thing. At least I can vouch for that. And then he has been working in this area for several years now. He's also the project and research coordinator, Morbe Development Foundation in Papua New Guinea. And he will take you through the basics of GIS mapping, take you through some of the data that kind of exists when we talk about GIS mapping. Similarly, let me introduce you to our next speaker. I'm sure some of you may be already knowing him. So we have with us Mr. Arup Das. Mr. Arup Das has been part of part of Aaranyak for several years now. He has been working in Aaranyak since 2008, and he's leading the Geo-spatial technology and application division of Aaranyak in the capacity of a manager. He has around 13 years of experience in the field of remote sensing and GIS. I hope our speakers will be able to address the expectations that our participants have also shared. So without much ado, I'll hand over to first Shaurya and then Arupta. Shaurya, over to you.
Uh, yeah. Hi everyone. So as Manisha introduced me, I'm Shaurya. So I'm member of Guwahati Shapers Global Community, Global Shapers Community. So basically today I will be, introducing you the various GIS tools, the concepts which are around it, how we can use the data which is around there, what are the various applications of GIS, especially related to water. So I will start. Just let me share my screen. So is my screen visible?
Yes, it is visible.
Yeah.
Yes.
Okay. So just a minute. Yeah. So what is geographic information system? So it is a collection of computer-based tools for organizing information from a variety of data sources, and mostly to map and examine changes which are occurring place on Earth, either due to natural phenomena or anthropogenic disturbances. Basically, it is designed to capture, store, manage, analyze, and visualize all types of geographical data. I will group it into data collection, management, and analysis. So a GIS has various components. So one of the components is data. So what is the type of data we are actually using for GIS? So it is actually geospatial data. So I would say it is also known as spatial data, but it is used to describe any data uh, about a specific location on the Earth's surface. So how do we, describe a specific location? Through latitude and longitude, through a coordinate system, which defines a specific location. And data is of actually of two types in GIS. One is raster data and the other one is vector data. So raster data, you can think of it as, pixels or grid cells identified by row and columns. And the whole geographical area is actually divided into individual cells, which represent basically different layers. So as you can see this image, the real world is a three-dimensional image, and each aspect of the real world can be, described in the form of layers in GIS. So for example, we have the elevation of a particular geographical location may vary, and this can be represented as a layer. Again, what is the land usage, like what is the land cover, whether there are forests or it is an urban area. Again, it can be represented as a raster layer. Then comes the vector data, which is basically composed of points, polygons, and lines. And these actually represent various other entities. For example, lines may represent the roads, polygons may represent particular buildings, and again or polygons may also represent political boundaries, administrative boundaries, and so on. So along with this, spatial data, there is with each of them there may be an attribute associated with it. So for example, on the right hand side you can see we have a point vector, and suppose this point vector represents a groundwater quality station, right? So this can be represented as a vector, but at the same time there may be an attribute associated with it, which may describe basically its name, and what is the name of the station. So the attributes are basically defined in a key value pair. So the both key and value, key here may represent the name, and value may represent what the name is. So basically the key is actually the parameter. Yeah. So next, going on to the software. So so these tools, actually we will need GIS softwares which will be used to perform these operations of capturing, storing, managing, and analyzing, as well as visualizing and creating maps. um, and there are different softwares available. So the most prominent ones which are being used now are ArcGIS and QGIS. And similarly, we need to have some hardware on which the software will run, right? So this can be a workstation, a laptop, or maybe remote servers, cloud-based servers, and so on. So now we are talking about, that there is different kind of data, right? So where is this data actually coming from? So this data can actually be, satellite imagery. These can be GPS, these can be analog maps, and so on. Along with this, there are some other related concepts, such as, as we know, the Earth is a sphere, not a perfect square, and we need to represent this it in GIS. We need to represent in a 2 dimension, right? So we need a coordinate system which can do that, and it follows a set of convention, which are followed around the world. So there are different coordinate systems. The most commonly used is the WGS 84. And then we have different data formats. So the spatial data, we have discussed about the raster and the vector data. So we have different data formats for each of them. So suppose for raster there's geotiff. For vector there is the shapefile, which is again a very popular format being used. Next comes next another concept which is related is georeferencing, which means basically the process of assigning coordinates to vectors or rasters so that they can be actually accurately be oriented for that particular location. So along with that, so I'll move to the next slide now. So as this workshop, uh, revolves around water management. So what are the applications of GIS in water management? So it can be related to water quality analysis. So how, it can be used to store data, capture, as I mentioned before, all the different operations for surface water, groundwater, and aquifers. Then similarly, it can also be used for, stormwater control and flood disaster management. So coming to that, as you know, um, during floods and storm, water will likely accumulate in different places. These places will be inundated, and this can prove challenging for, the rescue teams and rescue operations if they do not have information about the flooded areas. So GIS can help with, giving statistics or some information on the affected areas, and how, even help them with evacuation, and along with various other systems such as weather forecasting and all. They can help in decision making. And aerial views and simulation of floods can be again made used by again used by the government for decision making. And then we have, as I mentioned before, for water quality, uh, basically I will say, since GIS can handle large amounts of data, you can actually use this data along with several other data which GIS can make use of, such as GPS. Like at a particular location, what are the measurements of water quality, how we can visualize them, and how we can actually analyze and make perform decision making with them. Then along with that, we have watershed management. And in watershed management, basically we can actually delineate watersheds. We can see how the streams and the flow of a of the river in a watershed and its tributaries is actually, the river is flowing. What is the flow accumulation? All these things can again be analyzed through GIS. And then something which is related to is hydrometeorology, which again, based on precipitation, evapotranspiration, soil moisture, and so on. So the government of India has actually a GIS platform of its own for water resource management. So it is known as Water Resource Information System, and it is a web GIS in the sense that the services, which a GS can provide. Basically, whenever you download us, whenever you want to, perform some operations with GIS, you need to download the software, install it locally, right? But on through this web GIS, you can actually access it as a web service through the web. And this is a single window solution, as it is written here, for providing consistent data information on India's water resources, uh, along with the national GIS framework guidelines, and with tools to search, access, visualize, and understand data. So I'll just show you what it is actually. So as most of you may belong to Assam, so this is basically an application which can be used, which which has all the data, um, basically the geospatial data related to groundwater. So here we can actually visualize the data. So if you can see, so let me change the year and let me select some years, random years. I'll select. So you may have previous sessions on groundwater, how groundwater levels may have deprecated, or the quality of groundwater is varying. So this can actually help you provide the exact data on what is actually happening. So as I told you, there are different layers. So so just let me play around with it. So these are the state boundaries. If you can see, right, there are there will be district boundaries as I zoom in. Just on it. Yeah. Similarly, there are the different river basin boundaries. There are the sub basin boundaries. And then now, as this is related to groundwater, let me also show you the groundwater stations which are available all over India. So I'll just yeah, remove the heat map. So as you can see, these are the various groundwater stations which are available all over India, and this data is stored and visualized, collected, all the operations which I have told you. So this is presented here in the form of this application. And if I enable the groundwater heat map, so it basically tells where you can, the meters below ground level, where you can basically find groundwater. So let us go to some just random area here. I'll go back here, and since we have provided some parameters here, I'll just submit this data. Now this data which you are seeing is for the entire India. How the let's remove this parameter. Yeah, how the groundwater is varying, right? Groundwater levels are varying, and this is the average. What you are seeing is actually the average of all the states. So let's zoom into a particular state. Here I'm choosing Assam. As you can see, again for Assam, this is showing the various averages of all the districts, right, along with the number of stations it has and what is the average level. So let's again zoom in to some district here. Maybe let me remove the heat map so that I can see the district name. Okay, yeah, okay, let me select it from here itself. I'll select Dibrugarh. Right, so as you can see inside Dibrugarh, these are the various stations which are available, right? And now suppose I can take this station, which is known as the Azori station. So you can see here the source is CGWB, and then the basin is the Brahmaputra River Basin. The state is this, and you can see the coordinates, and this is the level. So basically, the below ground level in meters where you can actually find groundwater. So as you can see, the level is varying. So what you can actually do, if anyone is interested, you can nearest to your location where you are currently residing, you can go to this GIS application, and you can check whether how the water levels are varying. And this what I'm showing is for years, right? You can actually even so sorry yeah, so you can actually even see in daily, monthly, if the data exists, and seasonal as well, based on the monsoon and non-monsoon period. So this is one of the applications which WRIS provides. So another thing is the surface water quality. So again, it works in the same way. So this is again for the state of Assam. You can see the total number of stations, the stations which are being monitored, and the number of active stations in the last year. Again, you can choose one of the districts. Maybe I'll choose Guwahati for now. Let's see. So Guwahati, as you know, is in Kamrup metropolitan area. Yeah, just a minute. Okay, it's taking time. Let me refresh. So all these are web enabled platforms. An important concept which is related to various applications, it is, I would say, it is inapplicable to all the applications which are there, be in any domain, is abstraction, so if you drive a car, you won't know how the engine works, but you would know how to operate a car, and you would be able to do that. Similarly, a lay person may not know how this data is collected or what is the behind the scenes work which is actually going on, but they can actually use this data to make decisions and come out with conclusion and do some analysis, right? So it's similarly to that. So this I would say this is I would say a little slow, so let's get back. There are some other applications as well. So here, from here, I would say you can download all the data which is available. It provides the reservoir data, the groundwater data, and the, on river points, what is the basically the level. And you can select the source. There are different sources here. You can select the state, and similar to the user interface which I had earlier shown, you can see the there is the start and step time and how you can do it. And then you can see it on station wise, district wise. The report will be generated based on what parameter you choose. So this is there, you can download the data. And now there is another map which I would like to show. So these are all the water resources, and so this is like kind of attributes. So you will be able to see, if I see here, so I've chosen some. Let me zoom in. Yeah, so this is basically, yeah, just a minute. Yeah, so you can see, right? So this is one of the area which is in concentration here, and you will be able to see the project, which is the various projects which are being carried out in this basin. Again, I would say you are free to discover and explore based on what is happening around you, and you can actually, I would say, maybe you can see something is happening of either whether the quality is going down. Similarly, there are other applications you can explore everything from here. So someone was telling in the chat, right, how we can use groundwater quality, right? We can use how GIS can help with groundwater quality. Again, you can check from here, right? Surface water quality is there. And similarly, there are other hydrometeorological data such as rainfall, transpiration, the soil moisture, that is the moisture content which is being held by the soil, and so on. And there are different projects which are being carried out, right? So this is a very, I would say, nice website, and it is a collaborative effort by various ministries, the Ministry of Jal Shakti and Department of Water Resources. Similarly, even ISRO may have contributed to this project. So again, you can find all this on this website. And let's go back. So now, important concept which I had actually covered was that we are, you know, uh, using data, right? And we GIS can actually use and collect data from various sources. So which I told was, it can be satellite imagery, or it can be GPS, or any textual attribute, or some maps which have not been digitized, they can be digitized, and so on. So based on this, now one of the important data is remotely sensed data. So I'll be covering remote sensing concepts here. Just a brief introduction, because this is a very important concept. Later I'll show you how to do flood mapping using satellite imagery. So this is an important concept, so I'll be covering this. So when the word, when someone says remote sensing, what comes to your mind, right? To me, I would say, since we are in the COVID-19 pandemic year, the pandemic is still going on. What comes to my mind is remote workplace, right? So we are away from our workplace, from our offices, and basically working, in isolation, right? And if I see the word sensing here, sensing means to detect something, right? So remote sensing is actually, I would say, the ability to acquire information from a distance without being physically present. Suppose, earlier, maybe in 1900s, if there is flood or something, you would have to be physically present at the location, right, to know what is the to maybe gather information about the flood. But there is a technique, called remote sensing, through which we can acquire information about any phenomena. Maybe it can be natural phenomena, or it can be anthropogenic events or changes which are happening place, right? So that is basically remote sensing. We can acquire it from, acquire information from a distance without being in physical contact or being physically present there, right? So now the question comes, how can we acquire this information, right? So basically we need something which can acquire this information. So I would say something which detects or gathers information can be called as a sensor, right? So we would need a sensor which can acquire some information. Now the next question comes is, where is this sensor located, right? uh, if we have a sensor, so we have to, acquire information from a distance, so where it can be located, right? So these sensors are actually located on platforms, and these platforms can be categorized into, space borne. They can be in space, they can be in, they can be ground based on the ground, or they can be airborne in the air, right? And similarly, now the question is, okay, we are acquiring some information, right? And we have a sensor which does this, and these sensors are located on some platforms. But now the question which arises is, what is this information that we are acquiring, right? We need some information that we are able to interpret and which can be useful to us. But this information at the same time should be able to detect, without being there, right? Without being at that particular location where an event is occurring, right? So this information, I would say, for us, is actually the electromagnetic radiations, or energy basically. So these sensors will be actually detecting electromagnetic radiations and recording wavelengths of the energies which it is receiving. So based on that, we will be actually trying to interpret things which are actually happening on Earth, right? So that is how remote sensing works. And then next thing is, what are the different categories of remote sensing? So as I told you, there can be different platforms, right? There can be different sensor types, and even the in electromagnetics, the spectrum which we have, right? We can have various wavelengths of energies that are being emitted. So basically remote sensing can be categorized based on these parameters. So if I go next, so as I mentioned already, right, these are the different platform types. For spaceborne platforms, so, these can be aircrafts, these can be UAVs or the drones, or even balloons. There are stratospheric balloons and some other balloons which are suited for remote sensing. So these are the platforms. Inside these platforms, there will be sensors which may emit light or may detect light or maybe do both, right? And there can also be a ground based platform, like a car, autonomous cars. These emit, they are able to self drive because they emit electromagnetic radiation, receive back some, amount of energy, and based on that they are able to create 3D models around them, and and basically uh, drive. So the next type, which is based on the electromagnetic spectrum. So as our our eyes, the human eyes are able to just see the energy which is or the electromagnetic radiations which are in the range of the visible light, right? So it is a very small, it is in a very small range, or it occupies a very small portion of the electromagnetic radiation. And if someone has a, if someone is not aware of what is electromagnetic energy, so it is the vibration of charged particles, I will say, traveling in the form of waves, and they can travel either through vacuum or space. And so based on the wavelength of these waves, right, and based on the wavelength or the frequency, which is the reciprocal of wavelength, these will have different energies, and these can be categorized as different waves. So we have the radio waves, which have we have microwaves, we have infrared, we have ultraviolet rays, we have gamma rays, we have X-rays, we have X-band,
Shaurya, are you there? Hello? 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 I think there is a technical glitch at Shaurya's end. We're trying to fix that. Shaurya, we are not able to hear you at all. So maybe you may want to exit and then enter again. Himadri, can you get in touch with Shaurya once, or maybe? Um,
Let me speak to him, Manisha.
I think that there's some glitch that's happening. Maybe in the meantime, what we can do is, in the interest of time, Mr. Arup, do you want to kind of start off, or should we wait for Shaurya? I think he has just exited. He might join back again. He's muted himself. So,
Orupta may address some questions also, some questions, basic questions
yeah,
regarding GIS mapping.
sure. Arupta, do you want to kind of start off, because this is similar things, right? So once Shaurya gets addressed, then he can start off again.
One question is
I think he's joined. I can see Shaurya.
Yeah.
Sorry, Arudha, sorry, you can continue if you want.
No. If Shaurya has joined, we can continue.
I think he's on mute. There is some glitch at his end.
Okay, then I'll continue.
I'm back. Sorry, I think I
yes.
lost connection. My Wi-Fi restarted.
Sure, sure.
Okay,
No problem.
where did I leave? Where did I leave? I was totally, I would say, in flow. I
Yeah,
don't know.
you were in the remote sensing slide, Shaurya. You were talking about the electromagnetic waves, the kind
Okay.
of magnetic waves, and it's
Okay, then let me share my screen again. Just let me know which slide I was in. Okay, can you see?
yeah.
Yes.
You were in the slide. You were in
Okay,
the slide
was
towards
it this
the
slide?
yes, yes.
Okay,
And you were talking about the
okay.
spectrum.
So I left long back then. Sorry.
Oh, you were going on and on. Oh, we're so sorry. Yeah, we'll have to hear it again, Shaurya.
Yeah, no problem, no problem. So let me start again. So I would say, so as I told you, let me share my screen. I'm now connected to my mobile, mobile hotspot, so it should not be any problem now. So I would say there are different type of platforms, as I told you, right? Now, next, the categorization, which is, is based on the electromagnetic spectrum. So what is actually visible, the light which is visible to us only occupies a small portion of the electromagnetic spectrum. And for those, again, who are unfamiliar with what are electromagnetic waves, so these are actually vibration of charged particles which can travel through vacuum and space. And these basically, I would say, they have a wavelength and frequency associated with them, and based on these wavelength and frequency, they can be categorized into various types. So we have the radio waves, we have microwaves, we have infrared, we have ultraviolet, and we have x-rays and gamma waves. And then I would say, so these sensors can either emit these electromagnetic spectrum, or these can detect the energy which is of these waves, which can again be utilized to perform decision making or analyze the type of information which the sensors are receiving. Next, let me come. So there are types of sensors. So based on the types of, there are two types of sensors, active sensors and passive sensors. So for sensors, I would say a very important or fundamental concept is illumination, right? So suppose uh, I would suppose if there is someone in a room and that person switches off the light, you are unable to see anything, right? Because there is no energy which is directed, or which your eyes, the human eye, can detect, right? So similarly, the sensors cannot detect anything if there is no illumination. Um, so so there are in active sensors, what we are actually doing is we are emitting this, that sensor will be emitting its own electromagnetic radiation in some it can be of any wavelength or frequency depending upon its instrument type or what its aim is. Um, and then we have the passive sensors, which will be actually being you will use the illumination or the energy which is emitted by the sun and reflected back to the sensor, right? So in active sensors, it is emitting electromagnetic energy and receiving it back, receiving the energy which it has emitted, and based on that um, energy, it is this energy is the information which it is collecting, and this is what we are saying here as the remotely sensed data. For passive sensors, sun will be illuminating the earth, it will be reflected back, and these passive sensors will be actually being be capturing this again electromagnetic waves. Next, I would say, just to give an example, we have drones. So the diagram which I have here, which I have shown here, is for satellites, right? The same holds true for drones, UAVs, or some other sensor as well. So if there is a drone with a camera, so it is just using the energy or the light energy which is reflected back, and that is the sun's energy basically. um, so this sensor, so it is basically, this drone with simple camera is I would say a passive sensor. Then there will be active sensors as well. there will be active sensors. If the drone actually uses a camera and that camera is using a flash, so it becomes an active sensors. So now depending upon the type of orbit, there are different types of satellites. So we have polar satellites which are in polar orbits, that is orbits which will usually pass through the poles. Then we have the geostationary satellites which will be mm, stationary with respect to a particular point. Their speed of I would say their speed will be equal to that of the rotation of the earth. And then we have the satellites which do not fall in any category are non-polar low earth orbit satellites. Next, there are some various open and free data sources which are available, and these data sources are actually, I would say, free of use, and these can be raster. As I told you, these can be spatial data, right? Raster or vector. In vector, they can be suppose line vectors, as I told you, right? These can represent roads or the streets. So we have the open street map here. Then similarly, we have the NASA's US GS Earth Explorer, which gives you the remotely sensed data, provides the remotely sensed data of various satellites. And then we have the European Space Agency's data portal. So I have listed down the various data sources. These you are free to analyze and explore, and these provide a lot of data. So let's start here. I will just go a little fast. So how this remotely sensed data, remote sensing data or remotely sensed data can help um, in water management. So it can, so there are different satellites which are listed here. So these have different type of sensors operating in different portion, they will be emitting different kind of electromagnetic waves operating in different portion of the spectrum, and they will be based on the nature of the waves. They will be, they will be suited to a particular environment, maybe snow or maybe groundwater. They may be used to detect groundwater and so on. So there are different fields, the water resources, the hydrological fluxes. There will be different indices which are developed, which can help us to, which can help us provide information on what is the severity of the droughts and so on. Then even what the area which has been flooded, these how basically what is the extent of the flooding and so on. These all this information can be provided by these remote sensing satellites, which are using these sensors, which may emit electromagnetic radiation but will definitely receive and capture or detect the electromagnetic radiation. So I have a use case here. So we'll be doing flood mapping. So the platform which I'm using will be Google Earth, and the region of interest I'll be taking is Assam, and one of the just some region over the Brahmaputra river. And the satellite data which I'll be using will be Sentinel-1. So the methodology which I'll be using is based on a UN recommendation, UN Spider. That's the, I would say, name of the department. So what is the Sentinel-1? So this definition which you are seeing here, this description is actually indirectly, I've taken this from the European Space Agency's website. So basically I would say it's a constellation of two polar orbiting satellites operating day and night. Why it is operating day and night? Because it is an active sensor, right? At night, passive sensors cannot detect any radiation, right? Because there is no illumination. But there is maybe thermal energy can be detected. But Sentinel-1 operates on both day and night because it is creating its own electromagnetic waves. Basically, it is using a synthetic aperture radar. So radar stands for, I would say, you may all know, radio detecting and ranging. So it will be emitting radio waves or even some portion in the microwaves. And this will allow us to acquire information related to some event, and here that event is floods. Another advantage of using Sentinel-1 or active sensor satellite here is that it can penetrate cloud cover. Otherwise there are other satellites which are unable to penetrate cloud cover. So we'll be using Sentinel-1. So it covers the whole the coverage is the entire Earth. So there are 2 satellites which are actually will be passing through the poles, and they can map the entire world once every 12 days. But since there are 2 satellites, they can do it in 6 days. So before that, I just want to show you how the satellite rotation actually, how the satellite revolves. So just a minute. So are you able to see my screen?
Yeah, Shaurya, we are able
Yeah.
to.
So as you can see here, this is a very old video. So this is how the satellite is revolving. So this is just for a single day for a single satellite, which is Sentinel-1A. So the area which it is, you can see the rectangles, right? Is the swab area. These are actually hundreds of kilometer squares, which it is actually, covering. So it will be covering like this. It will be revolving around the poles, and this is just for a single day. So you can think of how in 6 days it can cover along with another satellite. So so maybe I'll just take a pause here for a few seconds. You can just see. So yeah, so here, if I'm correct, in the end, it would be going through the northeast region here. So that's how the satellites are, basically they are traveling in the orbit. They are emitting electromagnetic waves. They are detecting it through the sensors which are located there. And this information is being processed and is made available to us. So we will be making use of this information. So coming back here. So basically, how do we interpret the image, which is, the information which are receiving? So, so if, basically, if it is a smooth surface, which is also known as specular reflection, the reflection which is happening is called specular reflection. So obviously, the electromagnetic radiation will be bounced off, which is also known, this is also known as the backscatter. It will bounce off and we won't be able to do anything. So this usually happens with, rivers. So if you see on the right hand side, this is a river and specular reflection is happening and it's totally black. As I told you, there is no, we are unable to detect energy, right? The sensor is unable to detect energy at that particular position. So it's black. Then we have rough surface, which, so rough surface, you will be able to get back some radiation may be lost. And again, it, so, basically what you will be getting is less bright, less bright, that particular location will be less bright. Similarly, we have double bounce backscatter. So this basically happens in urban areas. And so you can actually see it as a very bright portion, and we are able to detect urban areas through this. So this is something about Sentinel-1. You can have a look. This is just an infographic which is available on the website as well. So next coming, what is the methodology which I'll be using? So I'll be using, as I told you, I'll be using Sentinel-1 imagery. And so basically I'll be using the GRD level 1 product, which already has, they have, the ESA and some other related organizations have already pre-processed the data. There will be, various, I would say, noises and various other things. So basically we have to pre-process the data before we can use it. So I will be collecting 2 imageries here for so one would be like before the flood and after the flood. So again, speckle filter relates to, something, so we have to remove some noises. So as you know, this Sentinel satellite is detecting some energy, right? So there will be interference between the waves and all. So we'll be doing something known as speckle filtering. And then so the before flood image, as I told you, right, the coverage is around 6 days. So we need to specify, give at least a 1 week period, so that in the duration for the before flood imagery. That is the time or what is the information which we have received, remotely sensed data, which we for before the flood has taken place, right? And then we will have remotely sensed data after the flood has taken place. So we'll be comparing them, doing some change detection, creating a difference layer, and then the difference layer will have some values. So before I mention, so actually all these operations, as I told you, this is raster data. All these operations are happening on pixel level or the grid level. As I told you, each pixel will have some information, and each this information will actually be used. This will be used. So here, if we have the difference layer, it will be having some information. So we will be applying some threshold value. Suppose that just to give an example here, that the pixel value is whatever data the pixel contains, it is below this number or something. So based on that, we'll be categorizing it as a flooded area or non-flooded area. Then we will be generating a binary flood map. Why it is binary? So each pixel will either be a flooded area or it will not be a flooded area based upon the change detection and the difference layer which we have done. So again, this area which we'll be using, there will be water bodies which are permanent. So we don't want to obviously detect it. We want to see where the flooding has actually taken place. So we'll be using some data sets which visualize the permanent water sources, and then we'll also using digital elevation models, something known as digital elevation models, which will actually, we'll be removing those flooded areas which have a slope greater than some number, because obviously the water will flow out and it won't remain flooded. Then we will so if there is a so if you visualize a pixel, right, maybe I'll visualize later, and when I will show you, then we have to exclude some pixels where there are particularly less number of pixels, flooded pixels basically. And once we have the processing processed flood map, we will be using different data sets for these again are these data sets. This data set which I have used here, suppose it's the DEM, right, the digital elevation model. So I'm using hydroshed data set. Again, this is coming from another satellite. It has its own characteristics. Similarly, we have the model this modest land cover data set. We'll be using this. Again, it is coming from another satellite, and we will be basically intersecting these and see what flooded area is actually intersecting with these, right? So we'll be able to get the affected urban areas, affected cropland, and then based on the pixel, how many pixels are being covered, so we'll be calculating areas. So maybe yeah, I will also tell. So each pixel actually represents, or each grid, as I told you in the raster data, right, it represents a particular region on the earth. So if the pixel resolution is suppose 1 kilometer, right? So suppose the satellite resolution is 1 kilometer, so that means the pixel of each, the pixel which we are getting, the imagery which we will be getting will be composed of various pixels, and each pixel will cover an area of 1 kilometer into 1 kilometer, which is 1 kilometer square area basically. So now let's quickly go here. So just a minute. So again, I have used Google platform, Google Earth Engine. You can easily log in here, and can you just give me a minute? Just a minute.
Sure.
Yeah. So basically, as I told you, right, I am basically actually here. Let me remove all the layers. I'll run this again. Just a minute. Right. So as I told you, right, I have chosen a region. So this is a polygon, right? I told you polygon comes under vector category, right, instead of raster. So this is a polygon I have chosen. This can be anything. I've just chosen here. There is, less, I would say this is an area with less urban population and so on. So I've chosen here, and let me actually refresh it. in case, because this session was long before. Let me refresh it just a minute. Okay. Here. So as you can see here, so I've already chosen a polygon. We can make our own polygons, or we can import a shapefile, which is again a vector, this shapefile can represent any administrative area or any district or any particular boundary. So here I have chosen just a random region. Now, as I told you, okay, so just maybe something brief. So Google Earth Engine just operates. I'm here using JavaScript. If I start, I would say mentioning about all the code and what actually the code is doing, it will be a series of workshop in itself, but you can actually see everything here. There are guides how to start, what is JavaScript. You can actually go through each of this, and you have to basically sign up. They will ask you to fill a form, and you can use Google Earth Engine. So basically it has all, it has an archive of its own data sets, which is stored. And so if I go here, so all these functions which I'll be using here, so all these functions are available here. You can actually see, if I'm just choosing another random function, so we are able to see, right? So all the explanation is here. So you can explore. I'll share the code and all. You can explore it. So now let's start. So if you see here, it's a polygon. It has 6 vertices, and these are the coordinates, just for your information. So now I have chosen a before start date. So I actually had chosen this so this is of 2021. I chose it on some news report that the monsoon will be, starting next week. So based on that, I have just chosen a before, basically the set of dates which will be chosen as a reference point for the flood detection. So here, as I told you, it takes 6 days. So you need to have that particular period. So I've just taken 15 days, just as a reference, but it will detect the first set of imagery, which is available. Next, there will be, so basically, maybe another thing which we have here is the after, this will actually be a series of imagery, the Sentinel-1 imagery. And these series of imagery, I will call it as a mosaic. So it will be a before mosaic, before flood mosaic. And next we have the after date. So this is actually based upon, again, a news report which I saw. I do not have those URLs open right now, otherwise I would have shown. Maybe I'll show it in the end if I find them. So again, this is like 30th August around this. So there was a report that the Brahmaputra river levels have risen. So this is just before the onset of the monsoon, and this is directly during the flooding when it has been reported. So another, as I told you, another reason why I'm using Sentinel-1 is it is able to detect, it is able to penetrate cloud cover. So before I do something else, I just want to actually show you, there is so we have the Assam State Disaster Management Authority there. Here you can use actually flood reports. So I was able to get some flood reports here. So you can see the flood reports there. So if you see here, so they are basically using remote sensing again, but they have used some other product. They have used the Morbe satellite, and they are using the sensor Aqua. And I suppose this is a passive sensor, because here you can actually see some label as cloud cover, right? So this would be a disadvantage, especially because if the flooding takes place in the monsoon, there will be cloud cover, right? So yeah, but they have generated a report, and they will be publishing these reports, I would say during the disaster event. So there will be something known as disaster event. They will be creating maps out of it. And there will be a disclaimer also that all geographical information has limitation due to scale, resolution, and all. So obviously everything depends upon the amount of information a pixel has, right? So if I say a pixel is covering 1 kilometer square area, right? So and if a pixel is covering 500 meter square area. So 500 meter square area, you know, the information level will vary, right? So all these, so this is a basic limitation of using remote sensing. But yeah, as you can see, they have shown the riverbank. They have, maybe let me zoom in. Yep. Let me, yeah, so they have shown the flood inundation which is happening, right? So similarly, and there is another report here which I was able to find. So this is, again, this is the flood reporting and information management system. I'm telling you all this because if something actually takes place, you know, in your vicinity, you can actually use these things which are available, which, you know, the state government is doing. You can make use of this maybe to, I would say, to alert, to be alert and make some decision, maybe move away from the area. So they are doing it for each district. They have what are the different relief camps and so on. So all this data is there. So but so what I'm actually doing is yeah, so now let's go back what was I actually was doing. So here I have mentioned some SAR parameters. So this is a polarization. So the electromagnetic radiation, it's basically polarization means how it is actually, you know, its orientation with respect to the antenna of the satellite, and its past the past direction, whether it is going from North Pole to South Pole or from South Pole to North Pole and so on. And then there is the difference threshold, which I talked about. This is again based on trial error. There are research papers which try to compute these, and I have here just chosen it as a you know, something based on trial and error. So again, this so I have so this is the area of interest. So the geometry is what is shown here. I have imported it. I'll just explain what the code is doing here. So basically, and this is the Earth engine. So as I told you, each of these, this Earth engine, so this Earth engine will basically have, you know, a set of its own function which will be doing, right? So it will be internally be doing something. Okay, so let me show you. Okay, just a minute. No, not this one. Image. No, just a minute. So there are actually dogs. Okay, yeah. So it will be calling its own internal library, and based on that library, it will be, you know, that library will have a function, and there will be the implementation of that function. I know it may be a little difficult for those who are not from the computer science background. So basically, you know, code built on top of code, right? We are writing some code, we are packaging it, which will be used in another application. So that application can be packaged itself and can be used in another application. That is how fast the software industry is, you know, evolving. So everything, you know, code on top of code on top of code. So similarly, we, you know, so basically I'm here loading and filtering the Sentinel data, the different, as I told you, the resolution. This is the transmitter receiver polarization, which I talked about. Whether it is vertically being sent or received, it totally depends upon the orientation of the satellite antenna and how the waves are being sent. And then we have, so here I'm setting the before and after collection. And then we have, so basically here I'm printing the, you know, I'm, you know, printing the tiles here. Its information will be printed here. And then I'm creating a mosaic. As I told you, it can be a series of images. Suppose we have the imagery which passes just through this area, right? But we are not getting this area. So maybe in the next day it will pass. So there will be two images, right? Which will be representing the before collection, right? So it will be mosaic. So basically, this is a mosaic of that area. And then I'll be applying some the speckle filtering, which I told you, to remove the noise and so on. Then so here I'm calculating the difference layer. And then now, as I told you, so I'm using different data sets. So this is the global surface water data set. Maybe I had it opened here somewhere. Okay, so just a minute. Yep. So if you see here, yep. So maybe I'll show you this. So this is a hydroshed data set. So all the information is available here. What type of data set it is a digital elevation model, giving information about how the elevation is. Based on that elevation, we can, you know, as I told you, we can delineate watersheds, how the stream network is, everything. So similarly, once it is here, So based upon whether the body is permanent or not, water body, we are removing, masking out those water bodies, and then we are masking out those pixels for which basically the slope is more than 5%, as I told earlier. Then we are able to calculate the flooded extent area. And again, there are some functions here. I'll just skip here. You can explore this. All these functions are again explained here. And next we'll be calculating flood area. So to hectares. So as I told you, the resolution is 10 meters. So there are again some calculations which are going on here. So now coming to, so let me actually run this. Yeah. Okay, yeah. So as you can see, it shows the flood status, which is for the after date, which is around August, around 30th August, right? And then it has calculated the number of exposed people. We'll come to this later, but yeah, let me show you. Okay, let me remove this as well. So this is what the satellite has given us. And as I told you in the presentation also, rivers are represented by black, right? These are smooth surfaces. There would be nothing reflected back, which the sensors can detect, right? So this is the, basically the river here. And then if I see the after, so can you see the change? The flooding which has taken place, right? But we need to detect this, right, properly. So as I told you, I created a difference layer. So let me remove both these layers, and there's a difference layer. So again, each of these pixels, these are actually pixels. If you see, just a minute, maybe I'll show you with some other data set. So these are actually pixels which are working out. So based on a threshold, I will say, every pixel will be assigned whether it has been flooded or not. So this is the flooded raster, I would say. And once that is here, so if I see the after flood, so this is the area which has been flooded. Now coming to this part, sorry, yeah, just a minute. Yeah. Okay, yeah. So coming to this part, as I told you, we have another data set which gives us the cropland. We have another data set which gives us the urban areas, right? And if I remove everything here, and let me change it to satellite. And actually, let me zoom out. Okay. So this imagery, which is shown on Google Earth, so this will be totally different, right? This may be taken 1 month back, 3 months back. No one knows how often it is updated. It totally depends. And so again, can you see the cropland? So again, this is from the data set. Again, from a sensor, we are getting some information. I'm using that data set directly. So this is the cropped area, right? The croplands. So if I go to another area, I will zoom in. So can you see, just let me remove this layer now. So these are basically cropland, right? So, and this layer is actually here, it's a set of pixels, as I told you. So can you see all these are pixels? So this data we are getting again, there is something associated with it. I'm not going into details. What we just want to know is that it is giving us the extent of the cropland in the area which we have chosen, right? Similarly, we have something called population density, where actually the population is. As I told you, I did not choose a big urban area or something. So maybe, so the white areas are the ones with population density. Now there is limitations. The limitation is that this data is actually old. It's 2016. There is no other data available. Again, the resolution is a little different and it's much greater. So that is again a limitation. So basically, less information for a particular pixel. So if I just go here, right? So you can see, right? Again, this is very old data set. The cities may have expanded and so on, right? So if you see here, yeah, this is all basically the population which is there. So let me go back now. Now, if you see here, if I show you the flooded area extent, right, and the cropland. So can you see there is an intersection which is happening, right? So this is the extent of the cropland which is getting affected and which is actually getting inundated, which I showed you here, right? see the intersection which is happening here, right? And so basically this is how the total, now as I told you, each pixel will correspond to a particular area, right, kilometer square or something. So we have I have converted here it into hectares, and you can check it, and it comes around 49,000 hectares. That's a very big area. So all this area has been flooded. So as I told you, this is what actually flood mapping looks like. Again, this can be done. There are other GIS softwares. It can be done. There are limitations for each sensor type, and you have to carefully choose what you are doing, basically. And yeah, so this is there. And actually, then maybe I'll just also talk about, as I told you, watershed delineation. So let me go to the hydroshed data if it's available, or let me go to the R. Yeah, just a minute. So again, this is another platform. So all what I'm showing are, these are web-enabled cloud-based platforms. All these are the whatever computations I am doing. These are actually happening on some remote server somewhere else. Similarly, along with R, again, it is used for statistical modeling, data science, and like there are full-fledged GS softwares, ArcGIS, QGIS, Quantum GIS. But there are programming languages which now are developing, their own libraries which can perform GIS related functionalities. Then I will just I'll come back to this. So here I will actually show you something here. So this is Google Colab. Here you can actually write Python. You can basically run commands here. So if I say, again, this is cloud based. So just let me zoom in. So if you see here, I'll say connect. So it says it's allocating some resources. Here resources means server, some RAM and some disk space it will allocate. So, and now it's connecting to Google Compute Engine backends. Just I'm telling so that you are aware what is actually happening. So it has given us a server with some particular RAM and some just disk space. Now what I'm executing is actually happening on that server. So as a user, I will, I don't have to do anything. I don't have to install, some dependencies related to Python or some software to do anything. I'm just doing everything on the web, right? So this is a particular advantage. So as I told you, so again, as I told you, there are libraries. So there are libraries which have its own functions, set of commands, which we can use, which whatever we are writing for the raster will be using it. So actually, let me try to run it. Okay, it's saying restart. I'll show you. So this is actually, let me log in again. So this is actually what I wanted to show you, some raster operations here. What is actually a raster, how it looks like, although I have told it in the slides, but still, yeah. Okay, let's see if it works. Okay, let me see raster data. Okay, yeah. So we have the libraries which are related to our GIS functionality operation loaded. So here I'm using a world claim data set which provides the data set from aggregated data set from 1970 to 2000. I'm using the temperature and precipitation data set. So just let me show you what actually is. Just a minute. Okay, yeah. Where I was, yeah. So we are specifying the resolution. Again, there are different variables. So and we are using what kind of data set. So once that's there, let me go to actually console. Okay, yeah. Okay, just a minute. Let's start here. Okay, so it's performing some action here. So can you see so this is basically a raster here. It has values of precipitation worldwide from the years 1970 to 2000. And what I have actually chosen is for the year January, the average data set. Next, so here I have added a vector which gives this, basically which will help us mask India. And then just let me show you what the raster actually looks like. So basically, these are different data types. So if I say raster, it is a 2-dimension array, right? So 2-dimension array will be, it will be represented, as a, if I show you here, let me show you, just a minute. Yeah, the operation takes time. So again, this will depend. Okay, just a minute.
Shaurya, will you be able to wrap up in 10 minutes? This is a very interesting session. I'm sure everyone is enjoying it, but in the
Yeah,
interest of
sure.
time.
Yeah, sure. So okay, now I'll just skip all this. So I just actually wanted to show how this delineation was happening. So I told you, right, watershed delineation. So we will be able to get hydroshed data, which is digital elevation. So based on the elevation, we will be able to form network of streams and so on. So here I'll just quickly go through it so that I do not miss at least. So this is the digital elevation map which I've shown here. This I've wrote it in Python. Then again, now we are calculating how the flow will happen for the particular grid or the raster. And then once that is here, just a minute. So this is a particular delineated catchment. And then just so far. So basically, this is the flow accumulation. Like we have some pixels. You know we are actually calculating the direction, right? Whether water will be going in which direction. So all these operations are taking on pixel level, and we'll be able to create a flow accumulation basically diagram here. And once that is done, we are also able to form river network. I won't go into details because we are running out of time, but yeah, so this is another nice feature of watershed delineation, which is which is available to us, which helps in watershed management. Now I wanted to discuss about, so this is one of my previous research papers. So someone had asked, right, how do we use GIS for water quality? Although I had shown, right, on the WRSIS WRIS portal, right? So this, I had actually done some research work last year as a United Nations volunteer. And so basically what we actually did was, so just let me go to the diagrams directly. So this is the Morbe Province, and like this is the country Papua New Guinea, and we have the Morbe Province here, and we have a watershed, the Bumbu watershed. So the city of Leh is there, and the Bumbu River is there, which passes through the city of Leh. And city of Leh is very important as it is the second most populous city of Papua New Guinea. So basically, there were reports that there is a lot of I would say pollution is happening and all, and we wanted to see basically, what are the various contributions. So just let me go to this diagram now, right? So we actually had chosen a set of points where we had taken GPS readings, and we had collected water samples. Now this is basically the map of the Bumbu watershed. There is the mainstream, then we have the left and right river streams, and then there are different classifications of the land. Basically we called it land use, land cover. And these classifications are basically so they can be forest, they can be mature forest, they can be agricultural lands, they can be urban areas, right? So what we wanted to do was that what is the contribution of, as the there is precipitation, right? And then as I told you, right, just before this, there is stream delineation, right? In the watershed, there will be various stream networks which will flow into the main river. So at these particular point of locations, what is the contribution of each of these classification, like how much water is actually flowing through forest and coming into the mainstream, right? And then we so basically we wanted to calculate. So that is something what the objective was, if I come back to the title, to estimate the relative importance of environmental and anthropogenic factors in influencing runoff quality. So that is something related. So runoff is something like the water which moves on the surface, right? So I will just go quickly here. So this is basically the water sampling points. And then if I come just down, just a minute. So yeah, I was talking about the GPS survey. So we had taken the GPS survey. Again, some GPS models were used. I won't go into much details here. So similarly, once we had taken the GPS survey, we had actually, if I say, So there's something called machine learning, you may have known, right? And there's something called supervised classification, unsupervised classification. So basically we use a supervised classification algorithm, the MLE clustering technique, which will help us. What we did is basically we'll tell that this pixel, this pixel will correspond to forest, right? Or this pixel will correspond to urban area. So we'll tell our algorithm that, okay, this type of information is related to that pixel, right? And then we are basically training it, then we'll be applying it all over the, all over a boundary, the watershed, to classify all these. So we had actually taken 6 categories: dense forest, region forest, semi urban, highly urban, and so on. And once these are taken, so this is the, if I zoom it in, yeah, so this is the classification map. So if you're able to see, we have highly urban areas, we have semi-urban areas, dense forest, regenerating forest, basically, maybe logging has taken place and so on. And then there's green space, which are basically agricultural lands, or maybe gardens, something like that. So once this was done, so let me go back here. Sorry. Yeah. So again, here actually what we had done. So as I told you, right, there are different raster and vectors. And okay, yeah. Just a minute. Yeah, it won't take much time from here. Yeah, so as I told you, right, there are different raster layers, vector layers. So we had used vector layers for them. We actually calculated the watershed, watershed raster, use the watershed feature. We are using iteracy test set GIS software, and then we use calculated flow runoff. So basically, what is the total accumulation, the flow which is coming to a particular pixel? That so each pixel will be having that number. Then basically, again, line vector, we have the road runoff. Then for raster-based GIS layer, as I told you, all these categories: dense forest, region forest, and so on. And then we have also calculated rainfall runoff. So why it is a point based? Because we had weather stations, we calculated. So we had taken readings from the weather stations, and we extrapolated it to the entire watershed. And once that was done, so so this was what I was showing. So this is the basically the line vectors, right? The road line vectors here, and this is the population, the habitation raster which we had used. And once that is done, so as I told you, so there were different weather stations. Based on that, we analyze the, totally the actually what is the amount of precipitation which is taking place over each pixel along the watershed. So again, there are limitations to this method, but so we have to do something, right? So obviously, we did that technique. Again, there are limitations, advantages, and cons, which we already mentioned. And next, here we actually able to depict. So these are, if you see, these are actually the relative importance values. So basically, if I say, suppose I'm taking dense forest, right? This is the dense forest raster based on the classification which we had earlier done. So this is the basically at each of these points, what is the level of the contribution to the runoff, which dense forest, that is what is the amount of basically what amount of runoff is actually going through the forest to the stream network. So similarly, we had done it for various other region forests, urban areas, and so on. So once that is done, we are able to calculate the values. These are the raw runoff values. These are the importance values at each of the sampling sites, which I told you. So once we have these runoff values, suppose now if I say this is a road runoff, right? The next step would be to have the samples which we collected to the lab. We need to do instrumental analysis. Suppose it is urban area, right? The quantity of bacteria, E. coli or something is there, right? That will be high in runoff area. So we can use that to see if there is a correlation between our values and what is actually happening. So if you see UC5 sample, the UC5 sampling point, the road runoff is very high. So that means, there may be pollutants related to urban areas, right? Similarly, like all these, there can be different pollutants. What is the correlation for each of these pollutants? How it is influencing water? All these can be done. Like this is again, this we had taken it for the next study, and like this was the actual aim of the study was to actually basically what I told, the importance of each of the factors in contributing or influencing the runoff. So you guys read this paper. It is available on the net. So as I told you, like there are different other sensors as well, right? it can be on drones and all. So just if anyone is interested, I'll share this paper as well. It was just published last week, not last week, yesterday itself. So this, we used the NASA JEDI. So NASA JEDI is the first spaceborne lidar. We had analyzed it to see how the canopy height variations are varying for the forests of Malaysia. Then this is for the spaceborne lidar, right? Now, if the so lidar is something, you are sending light pulses, and once you are again trying to get back information from what the whatever pulses which you have sent back. So you are basically detecting that, and suppose you can do that same from the right drones. So there's another paper which we had used, UAV. Basically, we had a radar sensor on a UAV, and we use that to detect individual tree to do individual tree detection. Suppose on the forest, over the forest, if we are able to fly the UAV with the lidar, how can we detect individual trees? These can basically help in various I would say various other steps. ITD is very important, like for forest uniformity, biomass estimation, and so on. So this is all available on the internet if anyone is interested. So again, these are different types of remote sensing, as I told you, right? These are different platforms. If I see JEDI is a different spaceborne. So it's a satellite, it's a spaceborne lidar. Here it's airborne. So like all these are actually practical implementations, and these help us to understand our surroundings and climate and everything, all the natural phenomena as well as anthropogenic events which are taking place. We are able to understand from that. So yeah, as we are running out of time, I'll move back. Yeah.
So Shaurya, maybe we can wrap up here because we also have Mr. Arup Das in the
Yeah.
session. I understand there were other things also you wanted to share. So maybe what
Yeah.
we can do is people can connect with you. Maybe you can share your email ID here.
Yeah, sure.
And they can all connect with you in this because GIS mapping in itself, like there are full-fledged courses on GIS mapping, right? So
Yeah.
I think your session today gave a very good insight about what GIS mapping is, how data, and where all can we find the data and everything. So thank you so much for sharing that. And maybe we can you can maybe stop sharing your screen, Shaurya.
Yeah. Yeah.
So maybe we quickly move on to Mr. Arup Das. Mr. Das, over to you.
Okay, thank you, Manisha and Shaurya, for your very detailed and wonderful presentation. As time is also limited, so I'll give my presentation within say 10 minutes so that other participants will get some time for discussions.
Yeah. Also, the participants can share their questions on chat, and if Shaurya, you can type it in the chat itself, so that Mr. Arup can also get more time. Mr. Arup, please use 15 minutes for your presentation. Feel free to do that.
Okay, so my slide is visible to all?
Yes, it is. Yes.
Okay. So very good evening to every participants as well as resource person. So I'm Arup Das. I am the manager of Geospatial Technology and Application Division of Aaranyak, and as Manisha already introduced me, so I'm in this field from the last 13 years. So I'm working in lab as well as I'm also doing field work, because field data is very much important for doing this GIS analysis using different softwares as well as the satellite data. So field verification is very much important. Okay, so last year one incident happened in Assam. If the participants they know, so this is the area of Tinsukia district. One area is there where oil well blowout incident happened during say on 27th May, and on the, if I'm not wrong, on 9th June actually fire actually happened in this area. So this is the oil well location, and the name of that location is Bagjan 5. If all the participants, they remember Bagjan 5, the area where blowout incident happened. This is just near to Dibru-Shekwa National Park. As I am from wildlife organization, so it is my duty to include actually some of the protected area, means say study areas. So I think this is the perfect area for discussions, so that at least participants will know the importance of remote sensing and GIS in this areas. So in this, there are two maps. In this area, you can see some of the drier part, means due to this condensate, this oil and gas, these areas, the surrounding areas of Bagjan 5 actually dried up. So we can easily, if we know how to digitize, and if we know how to download or how to select properly the date of that satellite image, and we can easily digitize using, say, Polygon feature, and we can calculate. So this type of actually maps are very much helpful for the decision making process, or some of the meetings. We can share these maps. Okay, and this location, this is showing the fire incident location, and these are the clouds cover, and these dark areas are showing this water body, because this Bagjan 5 is very much near or adjacent to Maguri Motapung wetland. That wetland is very much important because lots of bird species are there, probably endangered or critically endangered bird species are there. And this wetland is surrounded by this grassland habitat. So it is very much important, and this water body is connected with the rivers which are flowing adjacent to the Dibru-Shekwa National Park. So which ultimately affect the aquatic ecosystem of that area. So recently, actually, I have written one pocket-sized book, mainly targeting the students or researchers or the forest officials, frontline officials, those who are actively involved in field work. So some of the important headings are there, so that the target audience can use this in field. And side by side, one is in English and one is in Assamese, because in Assam, mainly I have written this for forest officials. So most of the frontline staffs are comfortable with this Assamese language. So I request all the participants, if you'll get some time, you can read. I think it will help you while doing GPS surveys in field. And yes, the cost of GPS are also very high. So some of the GPS apps are also available. So here I have included GPS Essential. One app is there. With the help of this app, we can easily save the point location in the form of waypoint and track. Whenever we can go, we can easily, these tracks we can save, and we can directly export this file in our Gmail, and we can open in Google Earth also. Okay, so for the participants, this sheet is very much important, because in most of the cases, people are collecting this GPS, this latitude and longitude in different formats. So it is very much difficult for those who actually prepare this map by converting these values in a point layer. So it is very much important to say mention properly the units of this degree, minute, second. So generally, while converting this values, so we can convert this into degree decimal. So formula is there: degree plus bracket minute divided by 60. In Excel, we can easily convert, and we have to save these in CSV, and we can easily convert this sheet in different GIS softwares. probably ArcGIS, QGIS, like that. Some of the useful softwares are there for GPS, Garmin, then Google Earth. Some options are there. Basecamp is also very much important, and GPS Essential mobile app. Okay, so we can also say upload say grid layer or sampling layer in GPS using different softwares, or we can also overlay the sample or the grid or the study area in Google Earth. We can plan for the fieldwork. So this is related to Garmin GPS Camp, and this is the GPS Essential, that is GPS app showing the point location as well as the track. And data sources. So in remote sensing and GIS, it is very much important for the users to know correctly actually from where actually we are getting the satellite data. So if I simply tell, okay, Earth Explorer, from Earth Explorer, you'll get the satellite data. But there are lots of options, how to download, how to select. So these are very much important. So there are lots of these videos in YouTube also. Means if you write how to download, say, Landsat MSS from Earth Explorer, so it will show you. So different satellite sensors are there. So you have to understand some of the ranges are there. Say in Earth Explorer, we are getting most of the satellite images. So from 1972, some ranges are there. So from 1972 to 1978, if you search the earlier or historical satellite images, we call these as Landsat MSS. So we can get the image from that particular time period. Then say Landsat TM from 1988 onwards till 2010. Then Landsat TM. Then Landsat 8. Nowadays, probably in future we'll get Landsat 9 also. So Sentinel, this 2, Sentinel 1. Okay, so there are two different, as Shaurya has already mentioned about different types of the sensors. Okay, optical, these actually the presence of cloud covers are there. If we download one satellite image and if we see the presence of cloud cover, means these are optical. Okay, then radar images, say Sentinel-1. So from Earth Explorer, we'll get all the optical remote sensing satellites, say Landsat, then Sentinel-2, then this is Copernicus. We can download say Sentinel-1, 2, 3, 4, 5. So Sentinel-1 radar data we can use, and DM data also is there. Then Naksha portal, as some of the basic data to prepare, say, river watershed or catchment area. For that, actually we have to depend on DM data. Okay, but in hilly area, say for example in Assam, say Karbi Anglong district is there. So if we use, I have actually tested and used the DM data. It shows the bigger area as a catchment. But if we use, say, Survey of India topo sheets having, say, contours, so we can easily delineate correctly the proper catchment area. So it varies from area to area. So if the participants they need the Survey of India topo sheets of 1:50,000 scale, so they have to approach to Survey of India. One office is there just near to Game Village in Guwahati. So if they don't know, if the participants they don't know what is the number of that particular topo sheet of my study area, so simply the GPS or the latitude longitude values will also help. So they will, the officials of the Survey of India will definitely provide the hard copy topo sheet, so you can scan and use. And some of the open series, this map OSM sheet from this Naksha portal we can download. So it is similar to topo sheet and it is the updated one version of 2005 and 6. So some of the areas we can get, and some of the toposheets are still in progress. So we can download free of course these toposheets from Naksha portal, but only thing is that contours are not available in OSM sheets. So if we need contours, then we have to approve Survey of India. Then other sites are there. Okay, so this is the site from where we can download. So if we don't know, these are the, suppose serial number, OSM number, sheet number is there, 78 and 12. Suppose we don't know anything about this sheet number, we know only the study areas. Say my study area is inside Kamrup Metro in Assam. State is Assam and district is Kamrup Metro. We don't know anything. We don't know the number. Simply search, the available toposheets will appear. So we can select and download, and we can see and we can read the places like that. So we can easily select the toposheet or OSM sheets from this. Some of the remote sensing GIS softwares, as Shaurya already mentioned about Google Earth Engine or R Studio, and this AirDAS is also very common software. This is also known as DIP, means digital image processing. Then ArcGIS, Google Earth is also say very much easy to use for the new researchers. Then QGIS. Okay. So this is the proper toposheets having contour lines actually, and this is the stream, main stream, and these are the orders, stream orders, first order stream. So there are different methods. Say Strela 1951. Say when two first order stream join, then the next order will be the second order. When two second order stream will join, then third order, like that. So we can also do stream ordering by digitization in software, or in by automatically with the help of DM in ArcGIS. Okay, and how to delineate catchment area. Suppose these are the mountain ridge, so we have to digitize from this ridge. Okay, so this portion will be a different catchment area, and this portion will be fall under in different catchment area. So this will be the catchment area of this river. So with the help of contours, actually we delineate catchment area with the presence of this stream, different stream orders. So like that. So sub catchment areas we can prepare. And as Shaurya already mentioned about this Sentinel-1, means flood mapping. I have not shown here the pre-monsoon say water spread area. Okay, so if I overlay the pre-monsoon water spread area, then the remaining areas will be showing as say flood inundation. So this actually I did in 2020 for Assam using Snap SN81 software is there. So I have not used this Google Earth Engine. So with the help of this also we can prepare flood inundation. So Sentinel-1 is very much important for Northeast India, especially for Assam, because during monsoon season the presence of cloud cover is there. So it becomes very much difficult to do analysis using this optical or the satellite images, say Landsat images or Sentinel-2, because of the presence of cloud cover. So if we use the Sentinel-1, so we can easily prepare the flood or do the analysis of flood mapping. So this is one case study of Kaziranga National Park and the adjoining area in different dates. Water spread area and inundated area like that. If we overlay the park boundary, we can easily calculate the percentage of water inundation inside any protected area. And if we observe, say 13/7 July 2020, highest actually water this flood occur in this particular date, but due to non-availability of Sentinel-1 data as well as lack of quality data of Lancer date because of presence of cloud cover, so it becomes difficult to do the proper analysis. Okay, so same the Bagjan area, and this is the landscape. The Shekwa National Park, Lohit River is there. This Maguri Motapung River is there. So water management as the top for today's topic. So this type of study is very much important. Means how much area has been affected due to this blowout or condensate, this oil and gas. We can do the analysis in this aquatic ecosystem, because this water body is also connected with the rivers inside national park, so which definitely affect the wildlife and the aquatic ecosystem. So we can also create some of the buffers and land use. Okay, so this is the area of Dipurbil, which is also considered as Ramsar site. So simply doing research or do the analysis in wetland is not very much significant. We have to understand, as we know that different rivers or say big drains are there in and around Guwahati city, which are connected with the wetland. Okay. So we have to understand what is the actually overall catchment area of this Dipurbil. So if we do, then we can easily prepare the catchment area and the connected channels, different inlet and outlet of different say wetlands. Okay. So indirectly, actually, water management, say, suppose this one is Brahmaputra River and Kaziranga National Park, then Orang National Park. So Brahmaputra River is flowing. So this river system is also very much important for the movement of wildlife because of this corridors. Okay, because outside of this river system, human or anthropogenic pressure is very high. So to conserve these areas, we have to do some of the studies by using this GIS remote sensing techniques. Okay, so field data is very much important, field visit. On the other hand, say remote sensing GIS is important, but at the same time, suppose it is basically depend on the scale of mapping. So large scale means the small area and small scale means the large area. So large scale means suppose a small area in detailed mapping we have to do, say in riverine system, say human populations are there and different embankments are also there. So we have to go with say PGIS, participatory GIS. So the local people actually they are well familiar with their local surroundings, so they can draw the pictures of this of their area. So we can convert this into say in GIS platform also we can also calculate the area or in which direction actually the earlier embankments were there, like that. So we can also use participatory GIS while using this remote sensing and GIS. So this map, this is one lake is there in Jammu actually. In 2020, I visited that area. This is also considered as Ramsar site. So suppose if the user agency, they want to do some analysis based on water depth. So depth meter is there, one instrument is there. So if we or simply supposing GIS platform, if we create say grid layer and we can upload this grid layer in say GPS and using board actually if we measure say water depth inside in each grid, we can easily get the values and we can prepare. Okay. In other terms, we can also calculate say volume in remote sensing and GIS, say different tools we can use. Okay, so water management nowadays, say in for example in Guwahati city, water scarcity is very high. we have to still in my apartment, actually we are purchasing water every morning. So this is the cases in most of the localities in Guwahati, mainly during the winter season. Okay, so we have to do some of the field work. We have to collect, say, groundwater level using say GPS, as well as we can measure the depth. We can easily prepare some of the basic tools in QGIS, also interpolate. If we collect the field data, we can prepare the map, say hotspot or interpolate, say techniques are there, and if we overlay, say ward boundary, we can easily observe what are the areas which falls under, say, scarcity of water, or where water is available during dry season, like that. So this is the case of same Guwahati municipality area, where I think 19 wards, different wards are there. So I have prepared this using Google Earth. I digitized every features using Polygon with assigning attributes and calculate the area, and we did lots of field work. Field work is very much important. If we prepare anything, say land use and land cover of any area, but for that we have to do some accuracy assessment. Field informations are very much important for higher accuracy and for our understanding also while doing the analysis or the interpretation of satellite images. Say in the case of Assam State Zoo, actually I prepared this master layout plan of Guwahati State Zoo. Different enclosures are there, so they need water for the animals. Okay, so the zoo authority, they have to plan means for water harvesting, because this is the hilly area and in the lower part some plain areas are there. So how to do water harvesting? For that they need proper GIS maps and all for decision making. So all these as we regularly say, as we know that Kaziranga National Park is famous for rhinos and other wildlife wildlife species, and lots of wetlands are there. So we have to I request all the say participants, they have to select some important area and do some of the analysis. Say how many wetlands were there in earlier days and what is the recent status, like that. So I did for Kaziranga. So similarly, Guwahati municipal area is there, and if we collect some of the field data in terms of water quality and all, we can easily prepare some of the simple maps which are helpful in management purpose and policy making. So I thank you. So thank you, and over to Manisha. Due to this time constraint. Okay.
No, this was very useful. Thank you so much. Love the concept of participatory GIS that you spoke about, and so true. Like, it's so important that we also consider fieldwork as much as we make use of the softwares. Thank you so much. We will quickly open the floor for question and answers. If anyone has any questions to our two speakers, Mr. Arup and Mr. Shaurya, please shoot. Any questions that you guys might have? There was one question one participant wanted to ask. So she found the entire session very interesting, and she wanted to know, to start off, which are the good online spaces where one can get trained in GIS and GIS mapping. So do you have any suggestions?
Whatever I know, I'll speak. Then I think Shaurya will give more information. Okay, basic hands-on GIS training for 1 week. Actually, Aaranyak is providing. as well as online, because due to this COVID situation, we are also providing one-to-one, only one instructor and one participant. Okay, online 1 month training, say weekly 4 days for 1 hour each. Okay, based on this, comfortable with the time of the instructor as well as the participant.
Right.
As well as in Northeast India, Northeastern Space Application Center is there in Shillong, Umiam, that is under ISRO, Indian Space Research Organization. They also organizing different nowadays online training. Okay, and if any of the participants wants to visit some of the ISRO center in South, say NRSC, National Remote Sensing Center, that is in Balanagar, and that is the only nodal agency which disseminates satellite images for India, as well as if we need some foreign satellite image, they provide. So we have to. So they also organize, say, 12 weeks, more or less 3 months, like that, residential training, or 1 week, or advanced training, say 2 weeks, like that. And nowadays under DST, one Bharati Vidyapit University is there in Pune. Okay, they are the nodal agency actually which provide level 1 and level 2 GIS courses, mainly the open source. They generally use QGIS and some say Google Earth Engine, like that. So this is the national level training across India. Actually, they organize. So you have to search. I have the link, and for level 1, actually in Guwahati University, still I think some of the seats are left. Okay, actually from Pune, actually yesterday they contacted me for some more say participants. Some 4 or 5 seats are still vacant in Guwahati University under Department of Geography for level 1 course. So I'll tonight so give the link to Manisha, so that if any participants are interested, they can join. This is for 21 days. Okay.
Sure.
So in Dehradun, IIRS is there, Indian Institute of Remote Sensing. Actually, I did some training there. They are providing some training, as well as if genuinely some of the participants, they wants to do some higher studies in this field. They are also providing postgraduate diploma in, say, remote sensing GIS, as well as a PhD degree. Okay, and in global level, one of the important is ITC Netherlands is there. Okay, so one can do masters or PhD in remote sensing, like that. Okay, so over to Surya.
As for me, I did not have any formal training. I directly referred to the docs, official docs, and codes which are provided by in research papers as supplementary data. So yeah, that is a good comparison, I would say. Like when you know the basics, you can read through the various functionalities or the various approaches which are taken. Right, each research initiative will have its own set of pros and cons, their limitations, and maybe you can go through them. I never took any official, I would say, training, so I may not be a good person here.
Okay, there is another question coming, which is how to interpret or convert an HDF data format to raster. Can you please suggest which satellite data should we use for LULC data?
Yeah, LULC Landsat should be fine for a start. And HDF, I do know that there are raster functions directly in you can directly convert them. It should be available publicly on the net for other, for ArcGIS, there is a tutorial as well. So you can just check that out. Maybe I'll share the link.
Arupta, do you have anything to add to this?
Okay, selection of satellite data depends on the scale and the size of the study area. If my study area is very much small, then I have to go with higher, means say good pixel size, say 10 meter, 12 meter, or 5.6 meter, like that. If my study area is very much bigger and the time is very limited, so I have to go with, say, medium resolution. Or for whole Northeast, you have to go with some of the MODIS data, say 1 kilometer by 1 kilometer. And it also depends on the objective of the studies. If you want to do the analysis, say land use and land cover for only the recent year, then you go with Sentinel-2, that is optical remote sensing, because the pixel size is 10 meter. In every 12 days you will get. And if you do the change detection, for that we have to also see the historical satellite images, this pixel size. So earlier, say if we want to do the change, forest cover change of any area in Assam or in other areas from say 1974. So we have to select, say, Landsat MSS. So we have to, all the participants have to understand clearly, means which data set we have to select. What is the time period? For example, Landsat MSS, the range is from 1972 to 1978. In that particular range, you will get the good quality. Suppose in 1975, you are looking for satellite image of 1975, MSS is there, but in that particular time, the presence of cloud cover is there, or the quality of image is not good, that then you can go with, say, 1974 or 1976, like that. Okay. So range is very much important. Then suppose I need say image of 1990. So lots of satellite sensors are there. Which one we have to select? We have to understand that one. So Landsat TM. If you select MSS and you are searching in 1990, you will not get any image. So these are some of the things we have to understand. Okay.
Let's see. So if there is any other question, or maybe we can wrap up. But this was a great session. If any of you want to actually share anything to our speakers, feel free to unmute yourself and also share. Dheeraj, are you saying anything? Yeah.
Yes, Manisha. I have one question. Like for my dissertation, I used QGIS, and for that I was I was searching for different kind of maps. So my question is that to Arup sir. So where can I find those maps necessary? And is there any website or any government site where can I find such maps?
Okay.
Let's say for example, let's for Guwahati only.
Okay. So maps and data are two different things in GIS. So generally we call as map means data. Okay. For your dissertation means your own work. You have to do your own work. Maps are the output things. Somebody actually prepared and you can use. Okay. So you have to acknowledge. So it's better you have to prepare your own data. Okay. Because you're doing the dissertation. And if some of the informations secondary data you need, then that is different. Say bioclimate data is there. And okay, so say for Assam, RSEC is there. Okay, then Asdama is there. Then in ANISEC website, you'll get, I have one link is there from where you will get some of the data, most of the data for Northeast, that that is actually under NESAC actually. So I'll provide that link also. So suppose for Guwahati city you need, suppose you do not have any data, say ward boundary of Guwahati city. Okay. So from where you will get this vector data or the boundary. So maps are different, data is different. Data we can divide into vector as well as raster data. So these things we have to be clear. Raster means the satellite image, all the topo sheets. And suppose if we don't know, or say for example, any forest office is there in remote area, they don't know about this remote sensing, satellite data or the topography, they don't know, but they are well familiar with their surrounding area. If they prepare the sketch map, that map also we can convert into GIS platform. Okay, suppose you need the boundary of Guwahati wards. Okay, Guwahati municipal wards. So you can search in Google, say, is there any available maps are there? If maps are there in say in JPG or in PDF, and you have to see the latitude and longitude values are marked over this map or not. If the lat-long values are there, you can easily georeference, okay, that word map in QGIS, in different softwares, and you can create your own or delineate your own word boundary. You can calculate, you have to you have to add different fields, say word name, total area, like that. And so this way, suppose if we don't have anything, so in this way we can at least prepare some approx boundary that is not so very authentic, but at least we can use. Okay, so likewise, as well as if you do any dissertation, you have to go in field and you have to collect data. Okay, so if you don't have this GPS, because these are very costly, minimum 8,000 like that. So nowadays lots of apps are there, you can collect data, and some of the secondary informations, lots of means GPS values are also means say there, or the name of places in different published reports or in paper. You can collect the secondary information, try to put the lat-long values using, say, if the name of place is there, you can search in Google Earth, you'll get the lat-long value, you can convert and prepare the maps, the basic maps. Okay, thank you.
Thank you, sir.
Thank you so much, Rupda. I'm sure everyone has a lot of questions and a lot of things to take back and process. So maybe what we can do is, since we are beyond time, maybe you all can write to Arupda and Shaurya. Arupda, if you can share your email ID and people can get in touch with you to know more.
Okay.
Shaurya, you have already shared your email ID, right? So you guys can get in touch with them, or you can write to us and we can connect you with both of them. So thank you so much for joining today's session. Thank you, Shaurya. Thank you, Arupda. It was a phenomenal session, amazing session. Gave us a lot of thoughts. I think I will be one of those people to enroll in the courses that you have mentioned. So I'm going to get in touch with you for that, Arupda. And I'm sure there are many more people who are excited to join the course and learn GIS. This is one of the 21st century skills that we all need to know as young professionals.
And
thank you so much.
and also actually I request Shaurya actually, because I'm not using this coding and all. I'm not well familiar with QGIS or Google Earth Engine. So I hope if I need some help from Shaurya, he'll definitely help.
Yeah, sure. Yeah.
Okay. Okay,
Sure.
then over to Manisha. Yes.
Sure, Arupda. You can always get in touch with him or us, and we, anyways, are working on this together. So thank you so much, everyone, for joining. I mentioned about a form, so it's time that we start giving thought to what exactly we want to know or do. What is our problem statement, the local problem that we want to address, the action items that you are thinking about to resolve that, right? So think about that. You want to talk to us about it, feel free to reach out to us, sharing this form, and hope to receive your responses in a week's time. I'll also share this in our WhatsApp group. And thank you. Good evening, everyone. Thank you, Arupda. Thank you, Shaurya. Thank you, Pranav and Himadri. Thanks so much.
Thank you, Manisha, for the opportunity.
Everyone.
Yeah, thank you.
Take care.
Thank you,
Bye.
everyone.